Okay, class. Effect of crystallinity on the properties of polymer. The properties of a polymer, such as density, modulus, hardness, permeability, and heat capacity, will be largely affected by its crystallinity. For a partially crystalline polymer, its crystalline and amorphous region will exhibit different properties, even though both the regions are chemically the same. So crystallinity of the polymer will definitely affect the density, hardness, permeability, heat capacity, etc. And there is a 100% crystalline polymer does not exist. There is a partially crystalline or 70-30% or 50-50% like that. So some part is crystalline, some part is amorphous. So therefore, if we take a partially crystalline polymer, then its crystalline portion and amorphous region, they both will exhibit different properties, even though they are chemically the same. For instance, the density of the crystalline region will be higher than that of amorphous region. So now density of the crystalline region will be higher than that of the amorphous region. Why so? Can you answer it? Yeah. Why the density is higher in the crystalline region? Because density is mass by volume, and in the crystalline region the mass is higher and the volume is low because it is compact. Therefore, the mass by volume ratio is higher in case of crystalline region. And in amorphous region, the volume is more and the mass is less. Therefore, the density is lower. Ultimately, many properties of the polymer depend on the percentage of crystalline material present in the bulk. So the percentage of the crystalline material present in the bulk will influence many properties. To illustrate this point, let's take the case of natural rubber of different crystallinity values and plot Young modulus values against crystallinity. Okay, so now I want you to understand how this crystalline material in the bulk influences properties. So for this, we'll take example of natural rubber, and in this natural rubber, we have different crystallinity values, and we'll plot Young modulus values against crystallinity. So what is Young modulus is nothing but stress upon strain. Okay. So the graph clearly shows that initially low value characteristic of an amorphous polymer steeply increases along with the amount of crystalline component in the sample. A comparison of the properties such as density, hardness, tensile strength, and fluctual modulus of two samples of polyethylene A and B, where sample B is more crystalline than A, brings out this point clearly. So here you can see as the crystallinity, here all polymers are not 100% crystalline or 100% amorphous. They have some percentage of crystalline component and some percentage of amorphous component. So here we have taken a natural rubber of different crystallinity values, because its crystallinity at some portion will be higher, then other portion it will be even more higher, and then even more higher like that. So and then amorphous region there won't be any crystallinity. So if there is no crystallinity, the Young modulus is also very low. Okay. But as the crystallinity increases, this uh, Young's modulus also increases. And Young modulus is a measure of the ability of a material to withstand changes in length under lengthwise tension. Okay, so withstand the changes in length. So first, it won't be able to withstand changes in length, but then as the crystallinity increases, it will be able to withstand the changes in length upon application of tension. So now what does this say? Plot showing dependence on Young modulus of crystallinity in a sample of natural rubber. Mechanical properties of two polyethylene sample different crystallinity. Here in this case, sample B is more crystalline than sample A. So here you can see density of A is low but B is higher. Then hardness should be of sample B is higher. Tensile strength higher. Flexural strength higher. So more crystallinity, all the property improves. Brings out this point clearly. Evidently, sample B has significant different physical properties as the other sample is less crystalline. Molecular weight too has a profound effect on a polymer physical properties. The combined effect of the molecular weight and crystallinity on physical properties is shown. So crystallinity versus molecular weight. Molecular weight on x-axis. If it is less than 1000, it is non-polymeric. If it is between 1000 and 10,000, it is hard, brittle, soft waxy, depending on the crystallinity. Low crystallinity, soft waxy, high crystallinity, hard, brittle. Then above 10,000, hard, brittle, or limb flexible. In case of low crystallinity, in case of high crystallinity, hard, strong, stiff. Dependence of physical properties of polymers on their molecular weight and crystallinity. Permeability. Permeability means entering into the substance. Is another property affected by crystallinity. Extensive studies have been carried out in this regard, as permeability is a factor of great practical importance, especially in the packaging industry. Here again, crystallinity plays a major role because permeability depends on the extent and rate of penetration of liquid or vapor molecules through the polymer matrix, which in turn depend on the physical structure of the polymer. It has been observed that the crystalline region puts stiffer resistance to the penetrating molecule than the amorphous region. In other words, crystalline polymers in general are far less permeable than the amorphous variety. Thus, we could say that as the polymer crystallinity increases, the permeability decreases. So crystallinity is inversely proportional to permeability. Crystallinity increases, permeability decreases. Permeability increases, crystallinity decreases. So crystallinity increases, permeability decreases. Inversely proportional, that you should remember. Permeability and enhanced crystallinity have some effect on the chemical degradation of the polymer. The acid hydrolysis of cellulose, for example, takes place at the amorphous region with more ease than at the crystalline region. Similarly, in the whole mass of a polymer, such as polyethylene or polypropylene, the amorphous regions are more rapidly attacked by oxygen than their crystalline counterparts. So the amorphous regions are very susceptible to attack by oxygen as compared to the crystalline counterparts. So this is all regarding how the crystallinity affects the properties of polymer. I hope you understand, read it again and again so that you get a better idea. Okay.